Okay, here we have number 2, 11,000 pound roller coaster going over the top of a 20 foot high hill. Speed given, loses energy on the way down. Determine the speed of the roller coaster at the bottom of the hill. So pretty obviously conservation of energy problem. So let's just draw out. So we're looking at state 1 at the top, state 2 at the bottom. We got a roller coaster here, 11,000 pounds. Height of the hill, 120 feet. And its speed of 22 feet per second. Okay. The loss on the way down is given as 140,000 foot-pounds of energy, and we want to find the speed at the bottom. Okay, so as with all energy conservation of energy equations, this one's pretty obvious. We'll set a datum at the bottom. We will write out, and I'll just abbreviate here, K 0 plus U, gravity 0 plus work in. I'll leave out the spring terms. There's obviously no springs in here. K final, UG final plus E loss. Okay. Writing out our initial kinetic energy, 1/2 mass velocity squared. The mass is 11,000 pounds over 32.2. So there's my mass, and the velocity is 22 feet per second squared. So that's my K0 term. My initial gravitational potential energy was mgh. Okay, this is the weight, so I'm going to just substitute the weight in there, 11,000 pounds times our height, 120 foot. All these terms should be foot pounds, so feet pounds in this term. This is a foot squared here, foot on the bottom, second squareds cancel out, so this will be foot pounds as well. Let's see, there's no work in. Okay, and the final gravitational 0 based on my datum. So finishing this off, that's going to be equal to our final kinetic energy, 1/2 11,000 over 32.2. I'm going to be lazy and not write units here. V squared, that's what we're looking for, and then plus 140,000 pound-feet or foot-pounds. Alright, so this is my equation. I can solve it. Let's plug that into our solver. Okay, let's see. 0.5 times 11,000 divided by 32.2 times 22 squared plus 11,000 times 120. This all goes to the other side for my solver, so it's minus 0.5 times 11,000 divided by 32.2 times, I'll use x as my unknown, squared, and then this went to the other side, so it became minus 240,000. Double checking my numbers, 1/2 mass velocity squared plus mg times h minus 1/2 mass unknown squared minus 140,000, and solve for that. Get a velocity of 85.97, so that looks like about 86. That will be units of feet per second. Okay. 86 feet per second.